Hello everyone, welcome to the Math Magician's Den. We're going to talk about limits here in this video, and these limits involve rational functions that have fractions within fractions. Now, how are we going to solve these? First of all, the first thing we should probably try is just plug in the number. If I plug 3 into this first problem, I get 1/3 minus 1/3, which is 0, over 3 minus 3, which is 0. If you've watched some of my previous videos, you know this is an indeterminate form. And an indeterminate form means I just can't determine the limit the way it's written. So we're going to try something else here. Okay? What am I going to try? Well, I notice there are two fractions that I need to combine in the top into one fraction. Because if I have a complex fraction, what I want to do is I want to take the top of the fraction and multiply it by the bottom, the reciprocal of the bottom of the fraction. Try to make it one fraction. Or there's a little trick to this. The least common denominator here, what would it be? My least common denominator, well, I've got a 3 in one denominator. I've got an x in the other denominator. It looks like the common denominator would be 3x. So what I'm going to do is I'm going to multiply the entire top by 3x, and I'm going to multiply the entire bottom by 3x. And why would I do this? Well, the bottom, all that does is give me 3x times x minus 3. And no, I'm not going to multiply that out, and I'll show you why in a little bit. But if I multiply by 3x here, 3x times 1/3, the 3's will cancel and just give me x. If I distribute here, I'm going to get 3x over x, which is just going to cancel the x's and give me a minus 3. Now again, do you see it in the question? I have common factors on the top and the bottom. And by the way, those common factors actually give me the 0 over 0 that was causing the problem in the first place. If I cancel those out, on the top I'm left with 1. On the bottom, I can plug in the 3 for x now. Look, x approaches 3. I'm going to plug in 3 for x. My limit comes out to be 1/9. I call this method using common denominators to simplify my expression and get it to the point where we can cancel out those common factors top and bottom that yield that 0 over 0 indeterminate form. So it's the same thing with this next problem. If I plug in 4, I'm going to get 1 over 4 plus 3, which is 7, minus 1/7. Well, daggone it, that's going to be 0. On the bottom, I've got 4 minus 4, which is also 0. Again, what we've run into here is an indeterminate form. So we're going to try something different. We're going to try that method that I was just talking about. We're going to use common denominators. Well, what's my common denominator? My LCD would just be 7 times x plus 3. So I'm going to multiply the top by 7 times x plus 3. And notice when I do this, all I'm doing is multiplying by an expression that equals 1. Now remember what I've told you, and if you've watched some of my other videos, you know I've said this before. There are certain parts of this problem you're not going to want to simplify. Well, the denominators are on the top, so the bottom, don't simplify it. I've got a 7, I've got an x plus 3, and a v. I've got to stick with my v's here. I've got a 7, I've got v plus 3, and v minus 4. And I've got to fix a couple things here. These are not x plus 3's, they are v plus 3's. Be careful of your variables. Even we people that work with it every day, we get used to using x's. Now, if I distribute on the top here, I think all of you can see the v plus 3 is going to cancel and just give me a 7. When I distribute here, the 7's cancel. But I got to subtract that entire v plus 3. So now I don't have fractions within fractions, which is good. So I've got the limit as v approaches 4. And on the top, if I simplify, I got a negative v right there. And then I've got a 7 minus 3, which would give me a plus 4. Do you see it? I have this factor on the top, and that is the opposite of this factor on the bottom. Notice v and negative v, 4 and negative 4. Those factors are going to cancel, and they're going to give me negative 1. And on the bottom, I still have the 7, and that's multiplication by 7, times v, which is 4, plus 3. Once you have canceled out those common factors that give you the 0 over 0 indeterminate form, you can just plug in your numbers. And on the bottom here, I'm going to have 7 times 7, which is 49. So my answer here is negative 1 over 49. And you notice if you find someone that teaches math, they like to do this. They start out with simpler questions and they make it a little bit harder and a little bit harder and just a little bit harder. And you can kind of expect that anywhere you go. Well, we're doing the same thing here. If I plug in negative 5, I'm going to get 4 over negative 16 plus 1/4. Well, if you look closely at the top, that's negative 1/4 plus 1/4. I'm going to get 0. The bottom, I got negative 5 plus 5. That is also 0. This is not well behaved at negative 5. It gives me a 0 over 0 indeterminate form. And again, what that means is, doesn't mean the limit does not exist. It means I got to try something different. Well, what's my something different? I am going to multiply by, on the top and the bottom, those common denominators, which is here 4 times 3x minus 1. Multiply the bottom by 4 times 3x minus 1. And when you do that, you're just multiplying by 1. So you'll notice also I never hesitate to write down the limit. I have not applied the limit, so I'm still writing the limit as x approaches negative 5. Watch out, your teacher in your class might be picky about that. If you distribute here, the 3x minus 1 is going to cancel. And you get 4 times 4, which is 16. Plus, if you distribute here, the 4s will cancel. And I get 3x minus 1. The bottom, I've still got 4 times 3x minus 1 times x plus 5. Now, let's simplify the top. If I simplify the top, and again, I haven't applied the limit, so I'm still writing the limit. The top, I get 3x minus 15. And on the bottom, I've got that 4. Well, that's not going to cancel anything on the top. I've got 3x minus 1. Well, that doesn't cancel anything on the top either. And then I've got x plus 5. And sorry, that should be a plus 15 on the top. That doesn't seem to cancel anything either. Well, the top can be factored. How can the top be factored? The top can be factored into 3 times x plus 5. Now I have a factor that I can cancel. I have the x plus 5s. And that's exactly what I was looking for, because again, that's your 0 over 0 indeterminate form. The top, I'm left with 3. The bottom, I've got a 4. And I'm going to take 3 times negative 5, which gives me negative 15 minus 1. This comes out to be 3 over 4 times negative 16, which is negative 64. There's my limit, everybody. So you can see if you have common denominators, if you have different denominators within a fraction, common denominators are going to help you simplify the expression so you can cancel out that 0 over 0 indeterminate form. Again, if you like this video, please hit the like button, and I really appreciate it if you subscribe to my channel. I'll be getting more videos out day by day, and hopefully these are helping you out.